Folks, yay, go team. Here we go. So I'm going to try and talk as fast as I can. So what is energy? Energy is what you have after you have 3 Starbucks, right?
Yes. No.
Right? Energy? Lots of energy? No, it's not. It is not what you have after you have Starbucks, okay? So let's move on and try to get this to work. All right, come on, click here. Does it do anything? It's not forwarding. Oh, there it is. What is energy? All right, we don't know. Nobody can you guys can't quantify it? Can you guys, does anybody want to venture kind of a guess? Natalie, you always have E equals mc squared. Oh, well, that's a mathematical sort of relationship of something. Angel?
Efficiency?
Efficiency? No, not exactly.
I think it's heat transfer.
No, it's not. Well, heat transfer is a type of energy transfer.
A measure of work.
There we go, right there. Okay? It's not a measure of work. It is actually, I believe, the ability to do work. Okay? So that is the classic simple definition of what is energy, the ability to do work. All right, so who had breakfast this morning? No? None of you guys had breakfast?
No.
Right? Well, if you guys had breakfast, if you did, right, that's energy, right? It's chemical energy. It's going to go in your body's going to translate it into something, and then you've got the ability to run rhino. You can work. Boom, yeah. All right, never mind. Okay, so, okay, good. So we got that. But wait, what's work? What's the definition of work? Anybody want to take a guess? It's a nasty 4-letter word, right? So what's work? See, that one's harder. So like that one, when I was putting this PowerPoint together a couple years ago, I knew the physics answer, right? The ability to do work. But then I stopped. It's like, wait a minute. What's work? How does physics define work? Well, it's a little more complicated than that. And yeah, this is algebraic over there, and this is calculus over here. And it's like, so, well, you know, what are architects? we're engineers who don't like math, right? And so, all right, fine. Part of the problem that we have with understanding this definition is that we're not always physically aware of work happening. Okay? So sometimes the processes that have work occurring in them are invisible to us. Okay? So let me ask a question. Are any of you aware of your body converting carbohydrates into glucose? You're aware of it? I mean, you can like literally, yep, oh yeah, there's that one took that piece of fat and turned it into sugar.
Oh, yeah, you could.
You're not aware of it, right? You're not aware of that occurring, right? But yet it's still happening. Are we moving right now?
Yes. Depending on your references.
But we're moving right now. Even if we were sitting perfectly still, we're sitting on the surface of a planet. And the planet is spinning. And while that planet is spinning, it's also going around the sun. And then theoretically, I believe our entire solar system is orbiting on something else. Right? So work is being done, right? Let's do it this way. So I hate cruise ships. I can't stand them. Right? But people that get on cruise ships, they've been on these new modern cruise ships, and you can't even tell the sons of BB beeps are moving. Right? I remember one time Hero and I were in Florida, and we looked down this street, and it was bizarre because it's like, you know, there were buildings on both sides, and it looked like there was a building at the end of the street, except the building was moving, and it was the cruise ship. It was moving, but I've been on them 3 times, 3 horrible times. And I can tell you right now that if you're sitting in the dining room, right, and you're eating food, right, you might as well be sitting in this room eating food, because unless you're out at sea, say you're leaving port and you're just eating something, you can't tell that boat's moving. Other than looking out of a window or something, it's like that thing is like you're just sitting there moving along and you can't tell it's moving. So right there, you're part of a system, right? You are a person inside of a boat that has an engine and propellers, and it is moving through the water. It is doing work. So the same way that you're not aware of work occurring at the molecular level of your body, and you wouldn't be aware if you were sitting in a dining room on a cruise ship with all the blinds closed, work happens within a system at scales that you might not be aware of. Okay? All right. Another aspect of being able to see work is this notion of force and displacement, right? And that ties back to, the cruise ship and the fact that there is a force being applied, that is, the propeller is turning and pushing water back, which makes the ship go forward. So displacement is the motion, okay? So you have to consider the system as a whole. This ties back to what we were just talking about. And okay, I'll be honest with you. If you want to know more about this stuff, take Phil's physics class or something. Okay. So somebody brought up this one right in here, right? Who was that? Somebody back there. What is energy? Oh, it's and I should have said, okay, what is that stuff? How many of you guys knew what the M and the C stood for? So a few of you, right? Energy equals, right? Mass times the constant squared, speed of light. How many of you guys know the speed of light?
It's like 1,000.
No, it's not 1,000.
6,000
No.
a second or something like that.
So one of the things that you guys have to be aware of is that every single thing that you can pick up or touch on this planet has mass, correct?
Yes.
So if I pick up this thingy right here, it has mass. This has mass. She didn't wince. I didn't pull her hair out. Her hair has mass. Everything has mass, right?
Yes.
Go back to this equation. So does that hair that I almost pulled out of Terumi's head when she wasn't watching have energy in it?
Yes.
It does. Every single thing that you can touch, including air, which is hard to touch, but you're touching it, right, has energy. It is energy. Everything is energy. At the atomic level, you guys know that there is a nucleus and there are protons and electrons all spinning around it or something, right? That little symbol with all the little thingies going around it. Is there motion? Is there displacement happening there? There is. And atoms make up everything. So energy is in everything. Okay, so now let's take a look at categories of energy. Okay, so one of the ways that people in physics areas, right, define energy, they break it up into two categories. They break it up into categories where something is happening and there is some level of motion or something is occurring, right? And they break it up into the other kind where something has potential energy. So I know James lifts. Other people in here ever lift? A couple of you? Weights? Yeah? What would happen to you if you ate nothing for weeks and you tried to lift all the time? It'd be hard, right? You probably wouldn't do well. Even if you didn't eat for 3 or 4 days and you tried to do weights, it would be hard, right? Because that food that's entering your body is turning into glucose, I believe, or it could be glycogen, I don't remember, something like that. And it is in turn being used by the muscles, right? In James's case, they're big muscles, right? To do stuff. And so this tape measure, right? If it's sitting down here on the floor, or that stuff that Hero just dropped is down on the floor, right? And I go down to pick this thing up. I just used a bunch of my stored up glucose. I have lots of it, right? to put it up there. That energy has been transferred into that tape measure. Because if I drop it off, right, it's getting rid of energy. So some of you are going, well, think of it this way. What if you were down here working on the computer and I pushed it off on your head? Do you think you'd feel that tape measure landing on your head? Yeah, and you would go, that had a lot of energy, it hurt. It got moving pretty fast. Okay, so understand that in physics, you can divide stuff into things that have potential energy and kinetic energy. All right? Okay, so again, potential energy is stored up energy waiting to do things. Chemical energy can be potential energy.
That's supposed to be like that, right? When you accumulate that in your body.
No, an apple has lots of potential energy. Right? A nice pork rind has lots of potential energy. Right? So, and again, that division line gets blurred because we already talked about the fact that the electrons are flying around every nucleus, and so there's work being done there. Right? And so there is a motion of motion in the electron. So it gets a little blurry, but at any rate, so it has the ability to do something useful later is another way to look at it. Okay? So kinetic energy, on the other hand, is when that stored up energy is being released. All right? Keep going. So common forms of energy, things that you guys are going to come into contact with. Heat. Heat is energy. Right? You go stand out in the sun on these cold days, right? And if you're in the shade, it's cold, but you go out in the sun, especially if you got a nice black shirt on, it feels good. That's heat energy kind of entering you, right? And it's actually not heat energy, but it is heat energy, and we got to be a little bit careful about that. And I got to stop this recording because I've already gone to, I want to be able to upload these to YouTube. So I'll stop it and we'll keep going. Actually, you know what? I got a little bit of time, so I'm going to finish these up. So there is energy in the form of light. And we have to be a little bit careful. Part of this video or the next video, we'll talk about what parts of light are heat energy and what parts of light are light energy. Motion, right? If I take this and I toss it over at Daisy, right? Catch Daisy. No? Daisy's like, nah, don't throw that at me. I've read you throw things. Okay, so that is a form of energy, motion, right? Electrical energy. Anybody ever got zapped by an outlet? Yeah, I've done electrical, and so it's like that's the most common thing when the little outlet is sitting out from the box. How do you want to grab it? Like this, this way, and where are the two connectors? On the sides. Ah! Every time. I've learned my lesson too many times. Chemical energy, we already talked about that, right? So food is a type of chemical energy. When it goes into your system, it turns into glycogen or glucose. And then gravitational energy. That is something sort of causing a force to kind of affect your body. All right, so I'm going to stop this here. How many minutes did I get to?